Hello everyone, let us solve this question. In this question, we are given a right circular cone of radius r and height h with a charge q uniformly distributed on its surface. It rotates about its axis with an angular velocity omega, and we have to find the magnetic field produced by it at a distance z from its vertex. So, to do this, we will consider an element at a height x. This element will be a ring with some charge on it, and since this charged ring is rotating, it will produce a magnetic field here. Then by integrating through all the rings over this entire cone, we will find the total magnetic field produced by this cone at this point. So since these triangles are similar, this triangle and this triangle, let's say the radius of this small ring is small r. So r by x will be equal to capital R by h. So radius of this ring is rx by h. This is the radius of this ring. Now, what will be the charge on this ring? We will calculate by finding the charge density and multiplying it with the area of this ring. So since this surface is slanted, it is like this. This element, this is x, and this small element is dx. But this length over this cone is not dx. It is greater than dx. Let us call this dl. If this angle is alpha, which will be equal to the half angle of this cone, then dl cos alpha will be equal to dx. Hence, dl will be dx by cos alpha. And cos alpha from this triangle is h over under root h square plus r square. The area of this ring will be the total length of its circumference multiplied by its thickness. Its circumference will be 2 pi r, so 2 pi rx by h multiplied by its thickness. Thickness is dl, which is this, under root h square plus r square by h dx. This is its small area dA. Now the charge density on this cone is charge per unit area. So total charge upon total area of cone. The total area of cone is pi rl. So pi r into under root h square plus r square. Charge upon area of cone's curved surface area. So when we multiply it by q by pi r under root h square plus r square, this will be dA into charge density, that is small charge dq. This will cancel out, pi r. So dq will be 2qx dx over h square. This is the charge on this small ring. This charge will be dq, equal to this. Now the magnetic field produced by this ring here will be mu naught by 2 I r square upon r square plus z square to the power 3 by 2. Z is the distance from this ring to here. So this distance will be z minus x, because this total distance is z and this distance is x. So this will be z minus x. But it is given in question that z is much greater than r and z is also much greater than h. Since x is smaller than h, z is also much greater than x. So z minus x will just be approximately equal to z. So this will be r square plus z square to the power 3 by 2. Now since z is much greater than r and r is smaller than even capital R, so z much greater than small r. So this is also approximately just z square to the power 3 by 2, that is z cube. So the magnetic field is simply dB equals mu naught by 2 I r square upon r square plus z square, that became total z cube to the power 3 by 2, so z cube. Now what will be the current? Since this ring is rotating with angular velocity omega, the time period of its rotation will be 2 pi by omega. Because angle upon speed, time is distance upon speed. So 2 pi by omega, this will be the time period of its rotation. Now in this much time, this much charge rotates. dq charge rotates in this time. Current is the rate of flow of charge. So current is dq by t. How much charge rotates per unit time, that is current. So the current is dq by 2 pi by omega. Substituting current here, we get dB equals mu naught by 2 I is dq into omega by 2 pi. dq is 2qx dx by h square multiplied by r square divided by z cube. 2. So dB is mu naught omega q r square and this will be small r square, the radius of the small ring. This ring radius. So this is small r square x dx over 2 pi h square z cube. Now radius r is rx by h. So this will be mu naught omega q x dx. R square will be r square x square by h square over 2 pi h square z cube. So dB equals mu naught omega q r square x cube dx over 2 pi h to the power 4 z cube. This is dB. The small magnetic field produced by this element. Let us copy it here. dB equals mu naught omega q r square x cube dx over 2 pi h4 z cube. By integrating it from 0 to h, x varies from 0 to h, magnetic field will vary from 0 to b. Here magnetic field, when there is no element, magnetic field is 0, and finally magnetic field is b. So b equals mu naught omega q r square over 2 pi h4 z cube. X cube dx integration would be x to the power 4 by 4 and limit 0 to h. So h to the power 4 by 4. This cancels out and we get b equals mu naught omega q r square by 8 pi z cube. In the question, it is given that the magnetic field can be expressed as n mu naught omega q r square over 4 pi z cube. By comparing these, we get n equals half or 0.5. This is the answer.